1.
Lights, camera, fractions.
Okay, so let's think about what we know so far. We know how to add and subtract positive and negative numbers. You guys are pretty good at that. Fist of 5, right? 5, 5, 5, pretty much everybody. That's awesome. And you know how to now multiply positive and negative numbers, right? Fist of 5. Felt pretty straightforward, right? Pretty easy. Okay. Now we're going to talk about dividing positive and negative numbers, okay? A negative, well, excuse me, I'll start with a positive. A positive divided by a positive, 10 divided by 2 is 5, right? Positive divided by positive is positive. There's no negative at all, right? So it's just going to be a positive. Okay, negative divided by a negative.
It would be a positive. No, it'd be a negative. Because it's the same. Yeah, because it's kind of like a family of subtracting. When you subtract like negative and positive integers, like when you subtract, you just add the two on top of each other, right? So it would be it would end up being a negative.
It would actually be a positive. And ironically, but no, I see what you're saying. It's interesting. It's confusing, right? I'm trying to think of ways to explain this, and I'm not quite sure I have a good way to explain it. You know, my concept, I was trying to use my concept of the opposite, like a minus sign means the opposite of, right? The opposite, but the trouble with that method is the opposite of means times. The opposite times a negative. No, the opposite of a negative is a positive. The opposite of a negative is a positive. I don't know how to do that. Yeah, do you have an idea?
Kind of like, I don't know if this is right, but it's like it's like how many times this like a negative number can go into another negative number, and you can't like
Well, that's a great way
have
to
that
think of it.
equal a negative number. It has
Yeah.
to be a positive number of times.
Yeah,
that
that's a
equal
great way to
the
put
other
it.
number.
Does that make sense to you guys? You hear that? That was a good suggestion. So then that's going to be a positive, all right? And now a negative number divided by a positive number is a negative number, and a positive number divided by a negative number is also a negative number. So does this seem sort of familiar?
Yeah, that's what we did yesterday, kind of.
It's like exactly what we did, except that I changed it to division, right? It's exactly the same thing.
And do you like how is
So
it?
it's because it's like the opposite of multiplication.
Right, exactly. It's the same thing. Yes, Silas.
Well, my sister actually taught me a trick to remember for division and multiplication.
Uh-huh.
And you think of positive as love, and then negative as hate, and then like you say it this way. So like for the first one, you would say like if you love to love, then it still equals love, and then if you hate to hate, then it also equals love. So like.
Oh, cool. That's cool. That's awesome. That's awesome. And if you hate to love, it means you're hating, right?
And then if you love to hate.
And if you love to hate, then you're still hating, right? That's interesting. That's cool. That's very cool. That's awesome. All right, so let's just try a few. It's not going to really require a ton of practice today for the lecture, so we're going to have some time for you guys to do the homework, and you may even finish the homework in class today, which would be awesome. But let's just do a few practice problems, because you will see division problems a little differently in different ways. Okay? So you might see 40 divided by 5, by negative 5. What would that be? All right. Is it positive divided by negative? It's definitely a negative. If the signs are different, right, we can use that same rule that we used yesterday. If the signs are different of two numbers, the signs of two numbers are different, and we're dividing or multiplying, it's going to be a negative answer. If the signs are the same, it's going to be a positive answer, right? Remember that from yesterday? right? So the signs are different. It's got to be negative. 40 divided by 5 is 8, right? Okay, how about this one? Negative 36 divided by negative 9. What would that be? It would be positive. Negative divided by negative is a positive. What's 36 divided by 9?
Positive 4.
Positive 4, exactly. Okay. Now, you don't always see them written like this. In fact, I rarely write them like this. You know, once you're in algebra, so often you don't do division the way you learned in 3rd grade and 4th grade and 5th grade. You don't, you can, but you don't very often. I don't, at least. I will do something more like this. Negative 48 divided by negative 12. Every fraction, if you don't know that, it's worth writing down. Every fraction is a division problem. And it's the numerator divided by the denominator, right? Top divided by the bottom. So this fraction line, you can just use the word divided by. So negative 48 divided by negative 12. The nice thing about a fraction when you have that for division is immediately I know, look at this, negative, negative, I just immediately, when I see two negatives, I just put a line through them, right? Does that make sense? See that? And then suddenly all I have is positive 48 over positive 12. And I know 12 goes into 48 4 times, so the answer is positive 4. Okay? So number 4. Let's say I gave you, I don't know, negative 64 divided by 4. What would that be?
Oh, 16. Negative 16.
Negative, because it's negative divided by positive. The signs are different, so the answer is going to be negative, right? And what did you say it was?
Negative 16.
Negative 16, yeah, that's correct. And then 5. But sometimes, what if I gave you something like this? Negative 4, parenthesis, negative 6, negative 2.
Then you
So what would I do?
You multiply negative 4 by negative 6.
Okay, and what would I get?
Negative 24. Positive 24.
I would get positive 24 over the negative 2.
And then you divide
Okay.
24 by
2, which is 12.
negative 2.
12.
Negative
12.
12.
Negative, right? Positive divided by negative, so it's negative 12. Exactly. Good job. Excellent. What if I gave you this? Is this? Oh, I think it is. 6. What if I gave you this? Negative 5 times negative 4 over negative 2 times negative, I don't know.
Negative 6.
8. Well, I'll do negative 6. Let's just do that. So what would I get? What would I do?
Oh,
You would get 20.
So 5 times 4 is
12.
20. Negative, no, positive 20.
Positive
And then 2 times 6 is
12.
12.
12.
And then, yeah. And then 12 goes into 20 once, and then there's 8 left over.
All right, so I'm going to just simplify it as a fraction, though. I could do a mixed number, but what goes into both?
2.
2. Anything else?
6.
4 does, right? So I'm going to divide the top by 4. That gives me 5, right? And the bottom by 4. That gives me 3 5/3. Right? A lot of times in algebra, the fraction is more valuable than the mixed number. So I'm actually okay with keeping it just as a mixed number, as long as it is in simplest form. Does that make sense?
Yes.
It cannot be in 20/12. It has to be 5/3. Okay. One thing I just want to talk about real quickly is signs with fractions, just so you understand this. If I say negative 2/3, okay? Notice where the negative is. It's in front of the fraction, right? That is exactly equal to negative 2 over 3. It doesn't matter where the fraction, where the negative sign is in a fraction. It's also exactly equal to 2 over negative 3. Do you guys see that?
Wait, I don't.
Understand that. How many negatives does this fraction have? 1. How many negatives does this fraction have? How many negatives does this fraction have? It really makes no difference where it is. Traditionally, that's kind of the best place to put it, in front of the fraction. But sometimes you're going to see them in problems like this where they're in the fraction. So my final answer, in this case, was positive. But if it had been negative, I probably wouldn't have put negative 5 over 3. I would have put negative and then 5/3, right? That would be most likely the way I put it. But if I put it like this, it's still true and correct. And if I put it like this, it's still true. But one negative sign makes the whole fraction negative. This is really the most correct way to put it because it's showing there's one negative sign and you've got the one fraction. Does that make sense? And then if you had negative 2 over negative 3, really, that is what? It's positive, right? So you would rewrite it as positive 2/3. You wouldn't leave it as negative over negative, right? Always simplify in those ways. But this is really important to know because especially as we move forward, start talking about slopes of lines, and so forth, and we start graphing, it's really helpful to understand that one negative sign could be anywhere in the fraction, right? Could be anywhere, okay? All right. I think that's it. I think that's all you need. And then, so I'm going to just end the lecture and let you guys work on your homework.
Bye.